Hi, I'm Pavlo Kuchmiichuk from the University of Rochester. Today I will present my work on creating silver data for coreference resolution in Ukrainian via translation, alignment, and projection. Coreference resolution is a well-known NLP task that requires clustering dimensions in text that refer to the same underlying entity. On the slide, you can see an example of a coreference resolution system in action. While the task of entity coreference resolution is relatively well researched in English, it remains uncharted territory for many other languages, including Ukrainian. One of the main reasons for that is the lack of annotated data to train coreference resolution models. One way of mitigating the data scarcity issue is to adapt the data collected for high-resource languages such as English. In this work, we present two silver datasets annotated for coreference resolution in Ukrainian, both of which are built using existing English labeled data as a basis. First, we manually translated the Wiener schema challenge dataset. Second, we used the machine translation model to translate text from Ontonotes 5.0 into Ukrainian, followed by automatically aligning and projecting annotations based on the cross-attention layer of an encoder-decoder model. Before discussing our approach to silver data creation in detail, let's give a brief overview of existing research for coreference resolution in Ukrainian. In Glibovets 2018, coreference resolution module is presented as part of the bigger complex information processing system. The module is based on a multi-pass filtering sieve together with a decision tree classifier. Pogorely and Kramov attempt to create a coreference resolution system for Ukrainian using a convolutional neural network, relying on word-to-vec embeddings. In Talanek et al., the authors continue this work, now training a BILSTM instead of a CNN and using Elmo embeddings. It's quite complicated to compare the scores achieved by these models, as the works all use different datasets and do not talk about the data in detail. In fact, only the dataset from Talanek et al. Is publicly available. On this slide, you can see an example of the data from this corpus. In addition to the coreference clusters, other relevant information about the tokens is present, such as part of speech tags. To our knowledge, this is the only publicly available dataset for coreference resolution in Ukrainian, and it is unclear whether the dataset was annotated manually or automatically, as the authors provide no specifics about the corpus creation process. Overall, the task of coreference resolution in Ukrainian remains under-researched, and high-quality annotated datasets are necessary to appropriately evaluate the performance of existing models, as well as to train new ones using state-of-the-art NLP methods. Now I'll move on to discuss the base English corpora and the approach we took to form the silver Ukrainian datasets. First, let's talk about the Wiener schema challenge dataset. A Wiener schema is a pair of sentences that have only a slight difference in words, but contain an anaphora ambiguity that can only be resolved with world knowledge and reasoning. Such sentences can be quite complicated for coreference resolution models to solve, while human readers usually easily deal with them. You can see an example of a Wiener schema on the slide. The pronoun he co-refers with the man in the first sentence and with son in the second. Although the Wiener schema challenge has been largely overcome as originally formulated, the problem of common-sense reasoning still stands as one of the major NLP challenges, and the lower resource setting makes solving the task even harder. We decided to manually translate the WSC dataset into Ukrainian, attempting to preserve the ambiguity of the schemas. On this slide, you can see an example of an English schema and its translation into Ukrainian. The resulting corpus contains 263 Wiener schema sentences. 22 sentences were excluded from the dataset, as no equivalent translation was found. As this approach to creating a dataset requires finding the middle ground between preserving as much original content as possible and maintaining the overall schema form, some schemas were changed. For example, in the sentence you can see, fish could not be translated literally, as it has a different gender in Ukrainian, so we used the word catfish instead. Similarly, while some of the Wiener schema challenge dataset pairs are grammatically correct in Ukrainian, native speakers may regard such sentences as less fluent than possible. The reason for that is the ambiguity itself. In fluent Ukrainian sentences, different devices would be used by speakers to remove this ambiguity. On the slide, you can see a gloss that illustrates this point. In the sentence 1a, one could omit the subject and the subordinate clause. In the sentence 1b, one could use a demonstrative pronoun instead of a personal one in English. This makes both of the sentences unambiguous in Ukrainian. While the Vinogrid schema dataset is tailored for complex cases of coreference, it contains few sentences, so it cannot be reliably used for training. Hence, we decided to build on top of Ontonodes 5.0 to compile a sufficient amount of data for further model training and evaluation. Ontonodes is a large dataset containing annotations of syntactic parse trees, named entities, semantic roles, and coreference. This dataset contains text of multiple genres and is multilingual. Ontonodes is the primary dataset for experiments on coreference resolution in English. It is used as a standard in CoNLL 2012 shared task. Our particular approach is to take this dataset, translate it with a machine translation model, align the corresponding mentions in the original and translated texts, and project the annotations using the obtained alignment. Let's talk about every step in detail. The translation and alignment needs to be done automatically, so we relied on using a high-quality machine translation model. Specifically, we chose one of OpusMT models, as they are easily accessible, they work with Ukrainian and English, and they are generally of high quality. After translating the sentences with the chosen model, different methods can be used to align the words in source and target sentences. This allows matching the spans corresponding to entity mentions in source and target sentences in order to project the annotations later. For example, embedding-based alignment allows extracting the embeddings from multilingual models such as MBERT and using it to predict the alignment. One more approach that can be used for this task is based on modifying the existing data to mark the specific entities in the source text. The marks then need to be preserved after translation so that the entities can be recognized in the target text. For the final dataset, we decided to use the attention-based alignment approach. Attention shows how the model assigns weight to different input elements. In case of sequence-to-sequence machine translation models, it is possible to use this advantage to see which source tokens the model attends to when producing a target translation. On the slide, you can see an example of the cross-attention of the zeroth head of the first layer of the model. You can see how the words align. We extracted the cross-attention weights for a specific translated sentence from the model, produced correct tokens from subtokens returned by the model, and aligned the relevant mentions. Here is an example. Projection is the next stage, and this part depends significantly on the format the base corpus is presented in. It turned out that the alignment and projection process is not trivial because of the level mismatch between the format the machine translation model expects and the text in the corpus. The attention-based alignment approach relies on automatically translating texts with a machine translation model. However, the model can only translate sentences rather than full texts. The whole text cannot be translated at once. Instead, every single sentence needs to undergo the process separately. The general algorithm to alleviate this problem follows these stages. First, we split the document into sentences. Then, for each span mentioned in a coreference cluster, we find the specific sentence it appears in. We modify the span indices so that they correspond to the sentence rather than the whole document. We modify the new span representations so that they include all the tokens in the span rather than only start and end word. After that, the source sentences can be translated via a machine translation model. Since we now know the mentions present in each source sentence, the overall task amounts to aligning the sentences, extracting the specific target tokens aligned with source mentions, producing the mapping between source and target mentions, and reconstructing the coreference clusters based on this mapping. Here is an example of a target coreference cluster for the silver Ukrainian version of Antonotes 5.0. We also conduct an error analysis. The most prevalent errors are connected with the reliance on the machine translation model. In some cases, the model produces the target text in a different language, which supposedly comes from incorrectly labeled data it was trained on. Likewise, the alignment fully depends on the cross-attention layer of the encoder-decoder model, which may lead to mistakenly aligning unrelated words and then including them in the coreference clusters. To conclude, creating new datasets is crucial in order to extend NLP research to the low resource setting. Labeled data for languages such as English can be effectively utilized for this task. We present an approach to efficiently create silver data corpora for low resource languages based on existing annotated data for high resource languages such as English. We demonstrate how the methods can be used to create two corpora for training and testing coreference resolution models for Ukrainian. The scripts for automatic translation, alignment, and projection, as well as the Ukrainian binary grid schema challenge dataset, are made publicly available. You can use the link or the QR code on the slide. Thank you for your attention. Slava Ukraini!